our planet getting its best look yet at the most exciting outer space object we have seen in years.
For a long time, classification was astronomy's quiet comfort. You didn't need to know everything about an object to know what it was. You could look at its orbit, its brightness, its spectrum, and place it. Asteroid, comet, centaur, interstellar visitor.
3I/Atlas, the third confirmed interstellar object ever detected by humanity. We found it in July of this year, a wanderer from another star system passing through our cosmic neighborhood.
The labels weren't perfect, but they worked well enough to organize the chaos. They gave scientists a shared language, a way to compare notes without constantly redefining terms. 3IATLAS broke that comfort almost immediately. At first, it was labeled the obvious thing, an interstellar object, hyperbolic trajectory, incoming from outside the solar system, no binding to the sun. Simple, clean.
It's a golden moment because we have as good a view as we're ever going to get.
Showing the object in stunning new detail, like this one from a civilian astrophotographer who says he captured 3IATLAS shooting across the night sky.
That part was not controversial. The trouble started when researchers tried to answer the next question, the one that should have been just as easy. What kind of interstellar object? Historically, that question has had two main answers. Either something behaves like an asteroid, rocky, inert, largely passive, or it behaves like a comet, icy, active, shedding material as it warms. There's overlap, of course, but the distinction has held up surprisingly well.
You've got this comet, the Atlas 3I comet that's going through at the moment, a fascinating thing that may be, what current estimates, maybe 7-8 billion years old. Has come from a distant star system.
Older than our solar system, which is only 4.5 billion.
Formed before the Earth formed. An unprecedented opportunity to observe material that's coming from a distant star system.
Even oddballs tend to lean clearly one way or the other. 3IATLAS refused to lean. Early observations suggested minimal activity, no dramatic coma, no obvious tail. That nudged it toward the asteroid-like category, but then subtle brightness changes hinted at something else. Not the flamboyant outgassing of a classic comet, but not the dead stillness of a bare rock either. Enough to raise eyebrows. Not enough to settle the issue. So scientists did what they always do when the data are ambiguous. They hedged.
I think this is what Carl Sagan meant, the reality of it, that this is something that formed before the Earth formed.
Right.
And is visiting our solar system and going back out into interstellar space. It's been traveling for something like probably about 7 billion years or something like this. Can you imagine if anyone is sat in that
and you missed your exit.
Going, oh, no.
7 billion years.
We'll go around again. We'll make a course correction and go around again.
Papers used careful phrasing. Asteroid-like interstellar object, possibly cometary, activity uncertain. The classification box was left half-checked. That ambiguity didn't last. As more data accumulated, 3IATLAS started exhibiting behaviors that crossed category boundaries in uncomfortable ways. Its motion showed signs of non-gravitational forces, something usually associated with cometary activity, but the expected signatures were weak or inconsistent. Its inferred shape seemed extreme, more elongated than typical comets. Yet its surface behavior didn't cleanly match asteroid expectations either. Every new characteristic pulled it toward one label while pushing it away from another. The deeper problem wasn't that 3IATLAS was weird. Astronomy can handle weird. The problem was that the existing classification system assumed weirdness would still fall along familiar axes: rock versus ice, active versus inert, bound versus unbound. Those axes stopped being sufficient. Internally, discussion shifted from "what is this?" to "what do we even mean by these categories anymore?" That's the start of a classification crisis, not a public meltdown, but a conceptual one. When your labels stop helping, they stop being science and start being habits. One proposal was to expand existing categories, add subtypes, create qualifiers, interstellar asteroid with weak activity, comet-like object with atypical outgassing, hybrid bodies, transitional states. This approach had precedent. Astronomy loves taxonomies. Given enough Greek letters and slashes, you can classify almost anything. But 3IATLAS made that strategy feel brittle. Each new qualifier patched one hole while opening another. If it was cometary, why didn't it behave more consistently like one? If it was asteroid-like, why did it show accelerations that shouldn't exist? If it was transitional between what, exactly? And why was it arriving from interstellar space already in that state? The uncomfortable implication was that the categories themselves might be too solar system-centric. They were built around objects formed here, under these conditions, around this star. Interstellar objects are immigrants from environments we've barely observed. Expecting them to neatly map onto local labels may have been naive. 3IATLAS forced that realization into the open. Some researchers argued that the crisis was overstated. Classification, they said, is just bookkeeping. It doesn't need to be perfect. Nature doesn't care about our bins. The physics is what matters, not the labels. That's true, up to a point. But labels shape thinking. They influence which models get applied, which assumptions go unquestioned, which comparisons feel natural. Misclassification doesn't just confuse databases, it steers interpretation. And with 3IATLAS, interpretation was already fragile. The debate grew sharper when comparisons to previous interstellar visitors entered the conversation. Each new object had been treated as an exception, a curiosity. Together, they began to look less like exceptions and more like hints of diversity. Not just different examples of the same thing, but genuinely different classes of things. If that's the case, then interstellar object isn't a category at all. It's just an origin tag. And everything beyond that needs rethinking. That realization landed awkwardly. Astronomy isn't used to revising classification frameworks based on a handful of objects. Usually, systems evolve after decades of data. Here, the data were sparse, the uncertainties large, and the stakes conceptual. Changing the framework too quickly risked overfitting. Not changing it risked forcing future discoveries into ill-fitting boxes. 3IATLAS sat right in that tension. Behind the scenes, classification debates spilled into proposal reviews and conference panels. Should observing strategies treat these objects like comets or asteroids? Which instruments get priority? Which models are appropriate starting points? None of those questions can be answered cleanly if the object's identity is unclear. Even nomenclature became a quiet point of friction. The shorthand scientists used in conversation, calling it the asteroid or the comet, betrayed assumptions that weren't fully supported. People caught themselves mid-sentence, correcting terminology, adding caveats. That hesitation mattered. It signaled that the old mental shortcuts were failing. The real crisis wasn't about 3IATLAS alone. It was about what happens when more objects like it arrive. If each one forces an ad hoc classification debate, the system won't scale. You can't build a coherent field on constant exceptions. So the conversation began to shift again, this time toward first principles. Instead of asking which box 3IATLAS belonged in, some researchers asked what observable properties should define boxes in the first place. Activity level over time, response to solar radiation, structural coherence, mass to area ratio, volatile content inferred indirectly, origin environment inferred probabilistically rather than assumed. Those ideas point toward a more flexible, behavior-based classification system, one that treats objects as points in a multidimensional space rather than members of rigid categories. It's an appealing solution, it's also disruptive. Such a shift would ripple through catalogs, software, pedagogy, and public communication. It would blur lines that have been clean for generations, and all of it would be driven, in part, by one stubborn object that refused to behave. 3IATLAS didn't demand this change explicitly. It didn't announce itself as revolutionary. It just sat there in the data, simultaneously fitting and violating expectations, until the discomfort could no longer be ignored. That's how scientific crises usually start, not with explosions, but with erosion. By the time the object began to fade from view, the classification question remained unresolved. Official labels stayed conservative. Databases made do with qualifiers. No grand reorganization was declared. But something had shifted. People were more cautious about assuming future interstellar objects would be like anything seen before. More open to the idea that origin matters in deeper ways than trajectory alone. More willing to admit that the solar system's taxonomy might be a local dialect, not a universal language. In that sense, 3IATLAS already changed astronomy, even if quietly. It exposed the limits of comfortable categories. It reminded scientists that classification is not just naming, it's theory embedded in language. And when the language breaks down, it's often because the theory underneath needs work. Whether the field ultimately revises its framework or patches it incrementally, the pressure point remains. The next interstellar visitor will arrive with expectations shaped by how 3IATLAS was handled. And if that visitor is just as uncooperative, the crisis will deepen. 3IATLAS didn't overthrow astronomy's classification system. It did something subtler and more dangerous. It made scientists realize that the system might not be ready for what's coming next.